Welcome to the Future of Data Centers, a mini podcast series from the viewpoint of server farmers and data growers. In this sustainability-focused series, hear from industry experts as they guide IT leaders on an important journey to combat climate change.
Hello, everyone. I'm Joel Makower, Chairman and Executive Editor of GreenBiz, and I'll be hosting this sustainability-focused mini-series with Arun Shenoy, Vice President of Sales and Marketing, and Sam Brown, Vice President of Engineering and Construction at Serverfarm, and journalist and writer Ambrose McNevin. Today, we'll bring you the first episode of our three-part mini-series on the critical and sometimes controversial topic of data centers and sustainability. The topic of today's episode is new construction versus modernization. With all the great strides made by the construction industry to address its carbon impact, all construction projects involve embodied carbon. It's been said that the cleanest data center is not powered by renewable energy. It's the one that doesn't have to be built. So to build or not to build, that is the question. But before we blast off, a little pre-flight checklist. I want to bring you our top 3 data center sustainability predictions from Arun and Sam. Arun?
Thank you, Joel, and thank you, everyone. Looking forward to the discussion. So I thought I'd be a little bit pointed in terms of some sustainability predictions. And I thought I'd kick off with the first one that is really kind of the demand side of the equation. So prediction number 1 for me is that all data centers are going to be running at a minimum of 80% utilization. So I think that's going to be quite an interesting topic for us to cover. The second prediction, and Joel, you talked about it just a minute ago, building new DCs, building new data centers should be the last resort. So I think that's my prediction number 2. Prediction number 3 is actually an old one, but I wanted to kind of reorder the words a little bit to make them more relevant to kind of this conversation today. And that is reuse, recycle, and reduce. And I deliberately put reduce at the end because I think generally speaking, for the next decade or so, I don't think we're expecting to see a reduction in demand, quite the opposite. So I think what we're going to have to do as an industry is to figure out how do we reuse and how do we recycle as effectively as possible.
Wow, 3 great ones. How about you, Sam?
Hi. So I think the number 1 prediction that I have for the green side of life in data centers is that regulation is going to become, from a government perspective, is going to become a much bigger factor in the decisions that have to be made. Also, sort of on the other side of that, I think that with the regulations, you're not going to see a lot of adoption, or you'll have people trying to get around those regulations until the biggest users in the data center space, the Microsofts, the Googles, the Facebooks, actually require their co-location providers and their teams to implement this. It's going to have to come from the biggest users before it's really widely adopted in the data center space. And the third prediction is that the cooling and power distribution technologies that are currently used are going to continue to get better, but I think it'll start happening in leaps and bounds as opposed to this really slow trudge that has been taking place over the last 30 or 40 years.
Great, thanks both of you for that. Let's get into this. There's been a lot of conversation about net zero. Most companies and a lot of countries have committed to that, getting to net zero carbon emissions by 2030, 2040, 2050. And there's a global pact across the data center industry to achieve that. But there's a lot more to combat climate change than just power and cooling efficiency. Is enough consideration being given to the environmental impact of the construction phase around data center? Sam, let's start with you.
The short answer is obviously no. And reason being is that from especially in our business, from a co-location perspective, being green doesn't necessarily turn into profit. It actually adversely affects our bottom line. Using low VOC equipment, adhesives and compounds, using locally sourced building materials, it just doesn't translate into being a more effective business. So I think that's the reason it doesn't get the attention that it needs. And until, as I mentioned in my prediction, until the largest users of capacity in our industry start mandating that it is a consideration, it won't be.
So a higher cost without necessarily a lot of return. Ambrose, how do you see this?
I think one of the interesting angles is the perspective in terms of the scale of what is happening and what is planned. So the consideration being given to the environmental impact of the construction phase, which I think is at the root of your question. A very recent 2021 report by one of the large global property management companies puts the top 10 largest data center development locations in terms of pipeline for new builds at almost 2,000 megawatts of power to be constructed. So for the layperson, that expands to many, many thousands of square feet of physical space that's going to have to be physically constructed. And I think those, we shouldn't ignore that. Those are going into markets in different locations around the world. And that's just for the top 10 markets, which include places like Northern Virginia, Singapore, London, Dublin, Chicago, kind of large places where the data center construction is planned. So each of those construction sites is going to be very kind of carbon intensive when you consider things of that scale. And I think what we know is that in those and secondary markets, there are many thousands of untapped and unrealized of capacity inside existing data centers that large organizations are actually running today. So, those new data centers may well be needed, but we think there is unexcavated capacity available today that could also be probably more readily brought to market with much lower environmental impact.
Arun, do you want to weigh in on this in terms of the embodied carbon that's in the data center itself before you even turn it on? What can we be learning about how to address that?
Yeah, and I think so. Let me just for the sort of benefit of the conversation, just kind of distinguish between what we would term operational carbon and embodied carbon. So operational carbon is really the carbon footprint associated with the running of the data center once it is operational. And there are clearly ways in which you would design a data center, in which you would build a data center, and in which you would run that data center that help reduce operational carbon. And that is important. And I think it's actually critical. Both of those things are important. And for us to be genuinely sustainable as an industry, we have to do both things. We can't pick, one over the other. Embodied carbon, on the other hand, is the carbon that is effectively in the building before you even turn it on. And that is the sort of carbon footprint that a data center operator inherits at the end of the construction phase. And it is the embodied carbon associated with production of equipment, the transportation of equipment, the construction of the facility, what's embodied in the steel, what's embodied in the glass, what's embodied in the concrete, and everything that goes to make up the data center. And the easiest way I would describe the two things in terms of their sort of quantum is that for each megawatt of capacity of IT that you create in a new data center versus an existing, you have about 4 years of embodied carbon that you make up in operational carbon before you break even, if you compare a new versus an existing. And so if you kind of reuse that sort of rule of thumb, that gives you, I think, a good indication that embodied carbon isn't the majority of the carbon footprint of a facility, but it is a significant proportion. And so if you think about each megawatt and say, if I put a megawatt into an existing facility, I effectively have 4 years of running before I catch up with the new facility. That's the sort of baseline that I think most organizations should consider when they're deciding, do I really need new, or, can I do something better from, in terms of existing infrastructure?
So that brings us to the question I asked at the beginning, to build or not to build. Obviously, as you said, the greenest data center is the one that you don't have to build. So how do we retrofit existing data centers to make them more environmentally responsible and as well as efficient and all the other things a data center needs to be? Arun?
Well, the first thing I'd like to say is this is not about only building new or only reusing. This is about finding the balance. And let's say, as I said earlier, as far as one of my predictions is concerned, our first focus should be to reuse capacity that already exists. And I think generally speaking, if you look at an existing facility, there are really two main subsystems in a data center. One is, the electrical, the power distribution side of the equation, and the other is mechanical. The biggest gains from sustainability really come out of the sort of mechanical environment, the cooling, the movement of air, the movement of refrigerants, pumps and chillers and, CRA units, crack units, etc. So that is where we can create the best impact as far as upcycling those facilities are concerned in terms of their sustainability. But at the same time, the electrical side of the equation does also have quite a lot to gain from, from these sorts of techniques. Generally speaking, most enterprises that built data centers 10 to 15 years ago engineered them in such a way to really make up for, and I would describe them as the sort of deficiencies of the software workload to elegantly fail over. So these systems were over-engineered because the software, the applications weren't capable, of switching to either an alternative location or a failback of some sort. And so electrical systems, for example, as I said, were engineered to, quite a high standard, sometimes 2N. So actually the removing of some of that infrastructure to allow workloads to benefit from, a much more effective, much more efficient power distribution environment, which is more along the lines of an N+1, again, as I said, create some, sustainability capabilities as well. So it's about addressing those two areas. But if I had to choose, I'd say, mechanical is where the greatest gains are, but there are plenty of gains to be, to be had out of the electrical environment as well.
Ambrose.
Just to put that in some context, Arun, there was another report out very, very recently talking about vision for the built environment. And the type of organizations that were backing this are the IET, the Institute of Mechanical Engineers, in the UK, the Royal Institute of British Architects. So serious bodies, and almost, on the first page, the first things they say is, we can no longer afford to ignore the impact of what we build. We need to get more from less. We now recognize more urgently the need to get more from the buildings, infrastructure, and natural resources that we already have. And I think when it comes to then diving into the expertise down to, as you say, about the mechanical and electrical power infrastructure, it is the organizations that are responsible for delivering those across the world that are also recognizing this is a requirement. This is the new imperative. We have to get more from what we have, because data centers are increasingly the important part of the social infrastructure and the built environment, and that cannot be ignored.
Yep. And I think it's worth adding to that is, so let's think about Serverfarm in the sort of middle of this sort of little supply chain. On the one hand, we've got the sort of demand function. And so those are the organizations that have to deploy capacity. They're looking for more capacity in more locations, in more regions, in more cities, etc. And then there is the supply. And again, as I said, on the supply side of the equation is the decision. Do I build new or do I reuse? The organizations that have supply in the context of reuse, in other words, enterprises that built data centers that are either too big or the wrong, shape, for example, or in the wrong location in terms of their requirements now, don't have the capabilities to re-engineer those environments for the demand that is required. The people that are looking for the demand are simply customers of demand. They don't have either the capacity or perhaps even the patience to re-engineer those facilities. And that's where, organizations like Serverfarm come in, to have the vision to be able to look at those environments, to say, I know exactly what I can do with this type of infrastructure, to make it feasible for, one of these modern day customers. And I think it's worth mentioning, modern day customers have a very different expectation in terms of efficiency, in terms of speed, in terms of capabilities, in terms of, operational prowess. So it's not simply I have this old building, how much would you like? There's quite a lot of Tetris to be played, in terms of, making that little sort of puzzle work for, the people that have the need.
Sam, you're on the ground as head of engineering and construction. What are you seeing as the sweet spot in terms of what's the low-hanging fruit, I guess, of what can be done to an existing server farm? Where are you seeing the biggest opportunities?
Yeah, I think that some of the stuff that Aaron touched on, legacy system architectures where you have 2N infrastructure, you have, cooling plants that are operating at really low temperatures or poor air management. I mean, that is 100% the low hanging fruit. It wasn't, as early as like 5 years ago, we were still convincing customers that hot or cold aisle containment was a good idea. It was a worthy strategy to implement in a data center. It's funny, data centers we're involved in what is seen as a cutting edge industry, software and everything that goes into, AI that, a data center facilitates, but we are horrible adopters of change. Transformer technology it's the exact same as it was, I think, in the 60s and 70s. It wasn't until like 2017 that, the Department of Energy actually mandated more efficient transformers. To my point, my prediction earlier, regulation had to come in to actually make this change. So there's so much low hanging fruit that it's really easy to implement. So I mentioned a few. The other ones that are, low hanging are, going even further. So don't think about going from like a 2N system architecture to a distributed redundant. Look at what some of the hyperscale guys are doing now. They're actually not implementing UPSs and batteries. They're taking batteries to the cabinet. Great idea. It saves a lot of money. You can actually modularize and scale that spend instead of putting in a huge battery plant that is built to, operate at however many megawatts. You just put in exactly what you need for that exact cabinet that you're deploying. Other technologies, I don't see these as much in the States. I don't know if it's risk aversion or, again, just a slow willingness to adopt new strategies, but there are facilities in APAC where they'll take, a highly conditioned power source to an A feed of a server, and then they'll take raw utility power with a generator source to the B feed. Again, you're just saving tons and tons of transformation in electrical conditioning, batteries, everything from going into your system. So it's a really long-winded answer to say, the low-hanging fruit today is still the same low-hanging fruit that I see from about 5 years ago. But there are so many great and creative ways to really maximize energy efficiency.
I just want to pick up on something that Sam just said, and he used the word tons. And we sort of colloquially use the word tons to describe tons of equipment, tons of space. But actually there's tons of carbon, that we're talking about here, literally tons. And, doing some of the things that Sam suggested, going even further into things like liquid cooling, being able to serve, super high density loads, actually allows us to save something else that is in very, very short supply, and that's space. So if I could take, 1,000 racks worth of stuff, and it sits in 1,000 racks because, let's say, that particular facility can, and I'm going to say only support 10 or 12 kilowatts a rack, that gives you a certain footprint. What if you could serve 50 kilowatts a rack or 75 or 100 kilowatts a rack because you're solving the cooling need, at the point that heat is being generated and very closely coupling all of those systems? That suddenly means you can take, 1,000 racks and turn them into 100 racks. And suddenly you have a very different space equation, which then means, again, going back to the reusing of facilities, something that was envisaged to be, let's say, a 2 megawatt data center, might in fact be a 6 megawatt data center without the need for additional space. Now, you have the other tons part of the equation. So, when you concentrate lots of stuff into a smaller space, you're carrying more weight in the building and so on and so forth. But again, a lot of those problems are not insurmountable by any means.
Well, it sounds like there's tons of great solutions out there. And that goes to Serverfarm's unique business model, which is really specifically around taking existing data centers and maximizing their efficiency and reducing their carbon footprint. Talk a little bit about that, Arun.
I might go back a little bit, if I may. And you'll recall at the start, I talked about one of my predictions was that data centers should run at least 80% utilization. Actually, a big part of our business is not just solving some of these real estate or facility issue problems. It's also helping customers solve some of their IT problems in terms of how much space they occupy, how much power they take up, how much cooling they need, how much network is required. And so we run literally hundreds of locations around the world where we're helping customers become more reliable and more efficient in the physical infrastructure space. So we're giving them the tools, we're providing them the services, we're providing them the resources to help them make the IT environment be essentially much more compressed. In an ideal world for us, an IT environment is going to use 80% of space, 80% of power, and 80% of cooling. Because guess what? You've paid for all of those three things. You might as well use them properly. And if you can do that, if we can make all of our customers' data centers 80% efficient in terms of utilization, actually they're going to stop the need for having to buy and find new capacity. So solving some of these problems at source, if you want to call it that, is actually a very, very reasonable strategy. But if you can also solve some of those problems at the other end of the equation, where someone has made a decision, to buy new capacity, and you can give them the choice to, either do it, using existing rather than new, then, we think we've got a great story and great experience. We've been doing this for 20 years, so we know how this works, and hundreds of locations tells us that, our customers really trust us to do that.
So the common denominator for measuring all this is carbon, and it's embedded, as you said earlier, in everything that's in the data center, and of course how it operates as well. Sam, as you look at the construction materials, cement and steel are obviously the most carbon intensive ones. So what kinds of carbon savings do you see in being able to modernize an existing facility as opposed to building a new one?
That's a great question. So this was, I guess, just happenstance that it happened, or maybe it was more than that, but I was watching one of the weekly news programs, and I probably should have known this, but this was news to me. I guess concrete is, if it was a country, concrete would be the third largest country in the world as far as CO2 emissions goes, which was a staggering stat to me. I actually had to look it up and fact check it because it just didn't, it was just so, out there. Just using that alone, if you reuse an existing building, you are making such an impact on what goes into the greenhouse gas emissions for whatever part of the world that you're in. And data centers, obviously from a real estate perspective, we're not the largest builders of capacity in the world. Commercial real estate, offices, residential, stuff like that still wins, but we are big. I mean, millions of square feet get built on a regular basis everywhere. So you take a small piece of that and try to contribute to the environmental stewardship of the data center industry. It's a huge deal. And right now, I mean, there is actually a very real profit and loss calculus that can be done because of the impacts of COVID-19. Supply chains are hurting. Steel I think it's up 300% from where it was last year. So again, reusing existing buildings, there's actually some financial impetus to do that. And I think you'll start seeing more of it for what it's worth.
Well, tracking the money is a pretty easy thing to do. We know how to do that, but how about tracking the carbon? Arun, how do we do that, and how do you communicate that? And how does that work?
So I think tracking operational carbon is actually relatively straightforward. It's a sort of a simple equation that says, here is the kilowatt hour that has arrived at my front door from the utility. It comes with effectively a sort of pre-factored carbon footprint in terms of what has been involved in the production of that kilowatt hour of electricity. I then do some useful work with that kilowatt of electricity. In the process of doing that work, by the way, I have some losses in my environment. So operational carbon is not complicated. It is also not complicated, by the way, to give our customers pretty much a real-time view of what that, we could almost create a CO2 ticker, for example, that shows them, what's going on in terms of kilograms of CO2. What is actually much more difficult, because it's one of these things that's quite hard to sort of visualize. And it's a little bit like, let me give you an example. So, you compare a Tesla, a full electric car with a fossil fuel car. It is very, very obvious that the operational carbon equivalent of a Tesla versus a petrol engine car, there's a huge difference. I think what we haven't done as an industry, and not just our industry, but lots of industries in general, but we're talking about the data center one here, we haven't done a particularly good job portraying what is really involved in embodied carbon. And so we, Sam and I and a few of our consultant partners, kind of batted this idea around for the last year or so, trying to say, how do we describe this in the most effective way to a customer? And I sort of touched upon it earlier in the discussion, is for every 1 megawatt of IT, largely the difference between a new data center and an existing data center is if I use an existing one, I can run for 4 years before I catch up with the total carbon footprint of a new. So if I were to compare them side by side, I effectively have a 4-year head start in terms of sustainability before I catch up with something like this. Mm-hmm. And actually you could argue that you never catch up, because it's one of these sort of, it's sort of a permanent offset. It is worth saying that there are some inefficiencies that an existing building will always have over a very modern, designed, fit-for-purpose facility. So over time, and generally speaking, somewhere between 8 and 10 years, you may well catch up. And it all depends on utilization and so on and so forth. But even if you did catch up, 4 years is a lot. 4 years is a worthy saving, for everyone to consider, especially if it doesn't cost you anything. And that, I think, is a very, very important point. We're saving a lot in terms of construction costs because we're not having to build a building. Well, we pass that saving on to our customers. So we're not, as maybe the industry was having to do 10 years ago, We're not asking people to make this very polarizing decision between you can either spend some money or you can be sustainable. You decide which one you want. Well, guess what? The decision was always one. We're now we're giving our customers the ability to do both.
Yeah. Well, so that brings up the whole notion of education and transparency, and really it's about storytelling. And Ambrose, I want to bring you back into this. What can you tell us about that in terms of how you can do that or how you should do that? What's the role of just communication in all of this?
I think there's a major role for communication, but I think to pick up something that Arun and also that Sam said, every sector has a different definition of speed. And the construction sector, the commercial property sector, the built environment sector, what a builder calls speed compared to what an engineer calls speed is very different or poles apart. And then when you consider that we're actually doing this for an outcome, which is an IT outcome, the IT people are said to be obsessed with speed, of it being here and now, of it being machine learning, being automated, being where we want it, but as we want it in this ubiquitous, digitally driven world that we operate in. So I think that is one thing to consider, because today, as Arun alluded to, this solution has always been, well, if you want to get some new capacity and you want to build new services and you need a data center, then let me introduce you to a building company. So you immediately go, well, that's 18 months now, because we know what the supply chain is in order to build this new data center, and then take in the modern context and considerations, which are what's the carbon cost of actually embarking on this project. So that's a massive consideration, which I think has been overlooked up to now for what most of the solutions that are being brought to the market. And I think the role of communications, the role of transparency and knowledge sharing, I think is the new phase that we're moving into. So if you look at what people are willing to talk about and being open and factual about what they're talking about their sustainability agendas, then there is some fantastic things going on with the hyperscalers and with the very large technology companies, where they've made these very direct fixed commitments about 2030 and being carbon net zero, and they're communicating them on a regular basis. They're communicating them every year. They've got sustainability reports. They're talking about real targets here, which is, as IBM did recently, said, this isn't just about buying renewable energy. This is about taking carbon out of the operation. That's the fundamental part, I think, which is most important. But I think, like most things, it's about making that commitment to actually keeping constantly reinforcing and communicating the message, not just sticking a flag in the sand that says, I've got a green data center, please don't ask me about it again for another 10 years.
Great. Well, thanks for that. Now that we've taken a little look into the future, let's give folks a view, a flashback into your own data center journeys. Arun, what year did you enter the industry?
1987.
Let the record show that he winced as he said that answer.
Well, the good news is I was 3, obviously, when that happened. So.
Great. Well, you've come a long way very quickly for a young man. And Sam, how about you? The first job in the industry?
I was a mechanical project engineer for a data center consulting firm right out of college. So I've been in the industry ever since.
And the rest is history. Well, we're going to put a wrap on that. Thanks for joining us, Arun, Sam, and Ambrose, to discuss what lies ahead for sustainability and data centers.
For more insightful episodes of the future of data centers, be sure to check out serverfarmllc.com/podcast for additional episodes available on demand, as well as other upcoming mini podcast series.